Here we'll focus on reviewing the syntax of the for each command, with a view to extending its scope to other queries. In GeneXus, the for each command is the main way of accessing the database. This means that, in general, its logic will be valid for other forms of access, such as groups of data providers, or grids with a base table in panels or web panels. To refer generically to any of these ways, sometimes we use the expression navigation groups. Of course, there will be some differences. For example, the language of data providers is declarative and returns a structured output, so the body of a for each command is not programmed in the same way as a data provider group. However, the clauses that can be applied to it are almost the same. Here we see the base transaction. But we also have all these others. The blocking one, as we'll see, only applies to for each commands and to for each commands that update or delete. Grids offer several of these clauses in properties, and what would correspond to the body of the for each is written in the corresponding load event, also refresh in the case of panels. In addition, as we'll review, although more restrictive, we have a query to the database when a data selector is executed in a where clause with the in operator. So let's review all the parts of the for each command and then go into some of them in more detail. The base transaction is optional and is used to indicate which table should be the base table of the for each. That is, the table that will be accessed to return a set of records. In the previous courses, we always used it, placing a single value there. In this example, we're indicating that we want to run through all the attractions, and for each one, we want to print the name of its country, for which it's also necessary to access the country table. We see that this join is located on the server. That is, it'll be resolved by the DBMS. When no base transaction is specified, GeneXus must determine the table to navigate according to the attributes indicated in the other places. In the example, as the only attribute inside the for each is country name, it'll choose country as the base table. Therefore, it'll print all the country names of that table, and here's a case where declaring a base transaction or not doing so changes the behavior. One case that hasn't been mentioned so far is when we specify more than one base transaction. There, a join or a Cartesian product will be made. In this example, where each attraction has a country and city, and so does each hotel, a join will be made. An attraction will be shown with a hotel of the same country and city, then the same attraction with another hotel of the same country and city, and so on, until using all the hotels of the same country and city of the attraction, and moving on to the next attraction, and doing the same thing again. It'll be listed several times, but the hotel will change every time, from those of the same country and city. If they didn't have this relationship, for example, if the hotels didn't have a country and city, each attraction would be listed with each hotel in the table. Therefore, a Cartesian product will be made. Let's move on to the optional skip clause combined with count. It allows skipping the first n records, n being the result of evaluating this numeric expression, and from there, keeping the following m records, m being the result of this other expression. In this example, we skip the first 5 attractions of the query in order to keep the next 10. This is known as data paging. Paging consists basically of dividing the information resulting from a query into smaller blocks. Among other things, this reduces the amount of data sent from the database server to the program. In the navigation list, an optimization will be shown, where we can see that this paging will be done on the server. That is, the DBMS itself will do it, and we don't need to worry about it. We could then specify a list of conditional order clauses with a maximum of 1 unconditional clause at the end to sort the information to be queried and returned. Conditions also allow us to play with conditional where clauses in order to sort by the same filter criteria and to specify more optimized queries. In this example, if the condition of the first order clause is met, that is, the country variable is not empty, it's sorted by country ID, and the following order clause is not considered at all. Since in this case the where condition is the same, the where will be applied, and the country filter will then be optimized. On the other hand, if the condition of the first order clause is not met, the second order clause is looked into, and since it's unconditional, it'll apply. As the where will not apply in this case, because the country variable is empty, all attractions will be displayed sorted by attraction name, and most likely not ordered by country. The order none clause, which we hadn't seen before, is written when we want to leave the order to be applied undefined, which means that it'll depend on the platform and may even vary from one execution to the next. Anyway, the order clauses that we write do not determine the exact execution plan that the DBMS will choose, because other considerations are also taken into account, precisely to optimize the database access. We'll explore this topic in more detail in another video. We also know that the order clause plays a fundamental role when implementing a control break between nested for each commands. In that case, it's not only used to order the information, but also, and more importantly, to establish the break criteria. There, the order clause cannot be conditional. The using clause allows us to incorporate more orders and filters, but centralized in a data selector object, which makes it possible to send parameters to it. In this way, we don't have to repeat those same sort and filter criteria explicitly in each query. As far as the for each is concerned, it's as if they've been written explicitly. It makes no difference. In fact, in the navigation list, it will not be possible to differentiate one form from the other. It'll look exactly the same, and there will be no indication of the data selector. This means that order, where, and using clauses can coexist without any problem. For the generated program, there will be no difference between this for each and this other one. The difference comes up when the data selector is used in another way, this time in a special way, when it's used as an executable query. This happens when we want to filter indicating that we only want to keep the records of the extended table of the for each, for which the value of a certain attribute is among those returned by this independent query. In the example, when we want to run through the categories table, keeping only those that are among the attraction categories of the independent query of the data selector. The data selector query, because of the attributes involved, is clearly of the attractions of countries with names after the filter. If not empty, if empty, all. In this case, we should consider the data selector as if it were another for each. This is why the attributes inside the data selector for this case will not have any relevance for the for each where it's being used. Thus, the base table of the for each will be category, and that of the query of the attraction data selector. We also saw the unique clause, so that if the indicated attributes are repeated for a set of records in the for each, only one is taken for processing in the body of the for each, that is, in the main code. Here we're running through the table of attractions, grouping them by category ID, and only keeping one record from the group, printing its category name. We also saw that this clause was extremely useful when in the code of the for each, we wanted to do an aggregation on that set of repeated records for those unique attributes. Something that otherwise we could not achieve, having the for each and the aggregation formula working on the same table. In this example, the for each runs through attraction, and so does the count formula. In addition, since we have specified the unique clause by category ID, the count will be made for the set of records with the same category ID in which it's positioned each time. In the main code block, we program what we want to do with each record of the base table that has passed the filters. Of course, if attributes of the extended table are used there, these records are automatically accessed and used. What can be programmed here includes writing another for each command, nested, an invocation to a subroutine or to a procedure, which, when executed, will return to whatever follows the invocation. If no record passes the filters, then the code specified under the when none clause will be executed, if it was specified, of course. In this example, it'll be when there is no attraction from a country of that name. Since it's assumed that nothing was done with the data in the extended table of the for each when this clause was executed, here we're not positioned in any record. So, if attributes are named there, where will they be taken from? It only makes sense to name attributes if they've already been instantiated. For example, in the parm rule of the object where this for each is located, or in another for each in which this one is nested. Of course, here we can write another query, another for each, use an inline formula, and so on. But it's as if they were written after the for each. If the for each is inside a procedure, and only in that case, in the main code, it will also be possible to assign a value to one or several attributes, in order to update the record of the base table and the corresponding records of the extended table. Here we update the attraction name attribute of the record of the base table in which we're in each iteration, and the category name attribute of the associated record of the category table, which is part of the extended one. We can also write a delete command to delete the record on which we're positioned, and it only deletes the record from the base table without performing referential integrity checks. Of course, we can also write a new command to insert a record into a table, but this goes beyond the behavior of the for each, which controls both updates and deletions. For either of these two cases, we have the blocking clause. It allows the operations to be performed in a buffer, and when the n records indicated in the clause are processed, in this example 10, only then are the operations performed on the database. That is, the database is accessed only once to process the n records that are being updated or deleted, thus improving performance. As expected, this same clause is also available in the new command. Finally, the when duplicate clause is used when you want to update attributes in the body of the for each that are, in particular, candidate keys, so their values must not be repeated. If in the main code, the value of one of these attributes is being modified, for the record in which the program is positioned in that iteration, assigning it a value that already exists for another record in the table, then the update will not be allowed. Remember that the unique index is used to perform this control. Let's imagine for this case that in the category table there already exists a record with category name France Attractions, and that there's a unique index by category name. So, for attraction 1, which is from France, when trying to update the value of its category name, which is museum, to France Attractions, since a uniqueness control will be made, the check will fail due to a duplicated key. There's already a record with the value 4. If the developer programmed a when duplicate clause, that's where he or she indicates what should be done in that case. If the clause is not written, nothing will be done with that record that was intended to be updated, and it moves on to the next iteration of the for each, where in this case, the same will happen when trying to modify the category name of the Eiffel Tower, which is 2. If the when duplicate clause is specified, then although we may think that we're still positioned in the record that caused the problem, we are no longer positioned to update. So, if we want to update the attribute or another one with another value, we have to write a for each to indicate it. In this case, we want the first update, which will never fail, to be performed. And, for the first attraction of France, it fails due to a duplicated one and executes this section. Next, for the second and last attraction in France, it tries to update and also fails. Then it runs this section, and the table will look like this. In short, all the clauses prior to the main code or body of the for each are used to filter the records on which the main code will be executed, in order to sort them, group them based on repeated values and process them once, or to indicate that they'll be accessed as a block when you want to update and/or delete them. Then, for each one of the records that pass these filters or the grouping, and according to the determined order, the main code will be executed. From the attributes used in all these clauses, as well as within the main code, it's often necessary to access records from other tables of the extended table, but not all of them. For performance reasons, only those will be retrieved, and this has some consequences. In this example, the trip attraction table will be run. It corresponds to the second level of the trip transaction, but attraction will be accessed to sort by attraction name, and because its value has to be printed in the output. Also, because from there, country city will be accessed in order to access country to be able to filter by country name. In addition, trip will be accessed in order to filter by trip date. But it's not necessary at all to access category. Therefore, if in the parm rule we receive in the category name attribute, contrary to what we might think, that filter will not be applied. Why? Because inside the for each, the category table is not accessed at all. So, after determining all the navigations of the object where this for each is located, when the implicit filter that comes from the parm rule is going to be added, inspecting each of the queries, no relationship is found for this for each, and it's not added. For the case in which we're in a procedure, and in the main code we want to update attributes that are candidate keys, the following happens. Let's suppose that we're processing the record n that passes the filters. That is, we are in iteration n of the for each, where the code for the previous n-1 records was already executed. And for that record, or one of its related records, by extended table, we're trying to update one of its attributes that's a candidate key by giving it a repeated value. Then, if there's no when duplicate clause, the update is not performed, and it moves on to the next record of the iteration, n+1. But if the when duplicate clause is specified, it's executed. Then the next record of the for each, n+1, is processed. The code in the when none clause will only be executed when there is no iteration of the for each, since no record passed the filters, or the table was empty. That is, if this code is executed, it's because none of these was executed for any record. As we've just seen, the attributes that appear in the code of when duplicate or when none, as well as those that appear inside the data selector when it's executed as an independent query, are not considered at all when determining the navigation of the for each. This is especially important when GeneXus must determine the base table of the for each, because no base transaction was placed. This is the end of this summary of essential concepts.